Hello, this is Simon Tong, and this is my lab number 3 for Physics 2212. So first, an overview. This lab focused on magnetic field of bar magnets and measured the field on just a normal iPhone with the app Tesla Meter. To begin this lab, it was very important to zero the measuring device out. This was so that the magnetic field of the Earth would not affect the measurement data that we were then recording. The goal of the lab was to find the path dependence of the magnetic field formula. After we'd collected all the data, we inputted all this data into Excel in order to model it and find that distance dependency and the magnetic moment of the magnet. We found this from the plot of the magnitude of the magnetic force and the distance from how far the bar magnet was from the measuring device. The two formulas we used in this were, first, the distance dependency formula, which is seen below as the magnitude of the bar magnet equal to k, some constant, times r, the distance from the point we were measuring from to the actual measuring device, the bar magnet to the actual measuring device, to the nth power, which is that distance dependency. Next is the Biot-Savart law, which you can see finds the actual magnetic field for that bar magnet. On to the data. The top data is the raw data of the distances of the magnetic field in the X direction. This was then used to average up and create our graph, which is seen on the next slide. Underneath it is the data for the off-axis field, measuring the magnetic field on all three axes from the phone, then found the corrected Y field, taking away the effect of the Earth's magnetic field on the Y component of the magnetic field. The bottom row of cells in this spreadsheet is the averages of those off-axis field numbers. Onto the graph of our data. The average distance for each magnetic field in the X direction was measured and then graphed, as you can see, and it is graphed as the ln of the magnitude of the field versus the ln of the distance between the magnet and the measuring device. From this graph, you can see we had a slope of negative 2.7816, and this actually became our n, or distance dependency. Our ln of k was negative 15.573, and that became our k, which was just 1.724 e to the negative 7th. And finally, our magnetic moment was measured to be 3.825. On to the Glowscript code. The magnetic field, both on axis and perpendicular to the axis locations, were measured, and then you can see we graphed those as the arrows. We found two on-axis locations with a scale of 1/2, then 4 perpendicular locations with a scale of 3/4. In these, we plugged in the magnetic moment and the observation locations into the dipole magnetic field formula, which was all done for us by the code. And then to actually find the net magnetic field, we used the 45-degree calculation with the observation location found in the lab, with the dipole formula again, using a scale of 3/4. To see more of my code, just click the link below. Finally, onto our additional questions. The first of which was, if you hadn't oriented your experiment to compensate for magnetic north and had instead laid out your meter stick at some intermediate angle with respect to the Earth's magnetic field, how would your results have changed? This would have led to the net magnetic field being different from what it was actually measured, as the Earth's